All right, guys, today we got combinations. Think about yesterday we did permutations where order did matter, and we talked about arrangements. With combinations, order does not matter. And the most famous example of what a combination is picking a committee. When you pick a committee of people, it doesn't matter which order you pick them in, they're all on the same committee. Whereas yesterday, if we're picking people or things, the order did matter. We talked about all the different orders, excuse me, there. But when you're picking committees and things, it doesn't matter which order. Those are called combinations instead of permutations. All right. First, I'm going to show you one longhand here. It says find all the combinations of the three letters taken from this set of 5. And remember, order doesn't matter. So if I take out A, B, C, that's the same thing as CBA because the order doesn't matter. Think about committee, that'd be the same committee. So I could do A, B, C, I could do A, B, D, I could do A, B, E. I'm just doing a system here. I could do B, C, D, B, C, E, and C, D, E. And that's all of them. There's 6. Now, yesterday, if I were going to take 3 out of the 5, I'll do my 5P3, and I would get like, let's see, 5 times 4 over 2. I get like 10. I need to punch that in to make sure, but I'm pretty sure that's 10. I get 10 instead of 6. So permutations usually more than combinations because the orders are more. So that's a little bit different. Now, I don't know if you saw that. I showed you how to do this in your calculator yesterday. Well, guess what? There's also a C in your calculator. You might have seen that yesterday. And here's what it looks like. Okay, combination notation, a combination containing k objects chosen from a set of n. So n is the bigger number. You're going to take k out of n. How many combinations can you do? That's the notation. All right, that's what we're going to punch in. Now your calculator is actually doing this right here. Just do an n factorial, the big number, over k factorial, n minus k factorial. That's a lot of factorials there. It's also called the binomial coefficient, and you can also write it like this. You can write it without the c and just put an n on top of a k. Now there's no fraction bar, it's not a fraction, it's just another, this right here, this notation is exactly the same as that, just written a different way. And you're gonna see, your book tends to use this a lot, and you'll see why, really, I guess, tomorrow, but they like that notation a lot. But don't get confused, same means the same thing. Okay, let's just try one. It says evaluate that. It's also could be written like this. So really your calculator is going to do this right here. It's going to do 7 factorial over 5 factorial, and then 7 minus 5, which is 2 factorial. So the two numbers on the bottom, I'm just showing what your calculator is doing. So the cool thing about this is when you start doing this, 7, 6, 5, 4, 3, 2, 1. That's what's happening on your numerator. Denominator is going 5, 4, 3, 2, 1. My dots aren't showing up. There we go. And then also 2, 1. So what's going to happen on these all the time is like this. 5, 4, 3, 2, 1 cancels with 5, 4, 3, 2, 1. So what that leaves me with is 42 on the top, 2 on the bottom is 21. Now you can also take your calculator and hit your 7 first like we did yesterday. Hit 7, hit your NCR button, hit 5, and I promise you it's going to say 21. But that's what it's doing. All right, let's read this one with me. Run by the state of Michigan, Classic Lotto 47 is a twice weekly lottery game with $1 million jackpots. For a wager of $1, a player can choose 6 numbers from 1 through 47. If the numbers match those drawn by the state, the player wins. Now, they don't have to be in the same order. They just have to be, you have to pick the same 6 numbers that the state draws. The order doesn't matter. So it's a combination like this. How many 6 number combinations are there? So I'm doing this, 47C6, or again, you can write it this way. Now this one's too big for me to write all those numbers out. So I'm going to punch it in the calculator here. I'm going 47 math PRB, number 3 is NCR 6, and I get this right here. Wow. 107375773. Okay, look at that. 10 million different combinations of 6. So what are your chances of winning $1 million? 1 out of that many. 1 out of 10 million. But people play it every day, thinking I'm going to win, which is okay. But you know, it's just $1, I guess. But very, very lucky to win that if you were to get it. Okay. Look at this. Imagine this. How many committees, told you, can be formed by a group of 5 governors and 7 senators if each committee must consist of 3 governors and 4 senators. So we have 5 governors altogether and 7 senators. Now, I want to train you for something here. Whenever you start seeing words like and anytime you're doing permutations or combinations or any kind of probability things, I want you to think it means multiply, because 9 times out of 10 it does, probably more than that. So what I got to do is, okay, I have 5 governors altogether. I've got to find how many ways I can get 3 of them. So I'm going to do 5C3. That's all the different combinations of the 5 governors I can get on the committee. And then I'm going to do this, how many different senators, combinations of senators. I have 7 altogether. I'm going to pick 4 of them. Now, because I'm doing governors and senators, I'm going to multiply those two. That's also a fundamental counting principle that we did the other day. All right, same thing. So 5C3, that's 10. 7C4 be, I see 7, 6, 5, 3, 2, be 35. So altogether, there'd be 350 different committees just from 5 governors and 7 senators, if you must have 3 and 4 of each. So you're going to see a lot of problems probably like that tomorrow. So if you need to stop it or whatever, do that. Got one more slide. Okay, this is just a summary. The differences of permutations and combinations. Let's go one at a time here. Permutations involve order and arrangements. Combinations do not involve order or arrangements. Permutation, how many ways can you arrange 3 books out of 5? It's like 60 ways, which is crazy. Given 5 books, how many ways can we select 3 of them? Only 10, because it doesn't matter. Order doesn't matter. If you're just going to select 3 books to read, it doesn't matter which order you select them in. So you hope you see the difference. Permutations is how many ways can you arrange them. Combinations is how many different ways can we select them. And the last one right here, placing books in different orders produces different arrangements. Here we go. The order in which the books are chosen does not even matter. That's what I've been trying to tell you without even reading that. So hopefully that makes some sense. And I hope you see the difference in what we're doing today and what we did yesterday. Permutation, order, and arrangement matters. Combination, order, and arrangement does not matter. We'll work on it as we always do tomorrow in class, and I'll see you then. See you, bye.